What's up? I'm Vin, and today I want to show how to use the power rule in calculus. So here is the power rule, and the easiest case we could look at is when we're taking the derivative of x to a whole positive number power. So something like the derivative of x to the third. And the way this works, if I use the formula really like in depth here, is we've got n is equal to 3. That's our power. So it's going to be 3 times x to the n minus 1. So we'd have 3 minus 1. And this just gives us 3x squared. So that would be our derivative in this case. Now, if I just come up with a few more examples here, let's say we take the derivative of x to the 10. If we want to speed this up, we're bringing the 10 in front. We have x to the 10 minus 1 is 9. So just one more of these. If I have f of x is equal to, let's say, x to the 20th power, then f prime of x, my derivative, is going to be 20x to the 20 minus 1 is 19. So these are the easiest examples that we could run into with power rule. But then this technique gets a little bit trickier the moment we do something like add a coefficient in front. So let's say I wanted to take the derivative of something like 5x to the 4th power. In a situation like this, I have to use the idea that the derivative of a constant times a function is equal to the constant times the derivative f prime. So in this situation here, my constant is 5 and my function is x to the 4th. So when I take this derivative, I'm doing 5 times the derivative of x to the 4th is 4x to the 3rd. So when I multiply these two constants here, 5 times 4 is 20, and I have 20x to the 3rd. But then once you get good at this rule, you can speed things up a bit. So if I made up another function here, let's say I had 10x to the 2nd power, the derivative of this function, when I bring the 2 down, I just know ahead of time that I'm going to be multiplying the 2 by 10, and I get 20 x to the 2 minus 1 is 1. So I could just say 20x to the 1st or just 20x. So that's the example when we have coefficients. Now the next challenge you're going to run into here is what do we do when we have negative exponents? So if I had a function like, let's say g of x is equal to x to the negative 2nd, the only problem people are going to run into with this is when they have to subtract 1 if they're doing this with no calculator. So you bring down the negative 2, we have x, but when I do negative 2 minus 1, I'm going to get negative 3. So just be careful. Some people, when they go through them quickly, they'll do something like 2 minus 1 is 1, so they write negative 1 here. But just know when you subtract 1 from a negative number, it's kind of like, it's going backwards. So the absolute value of the number gets bigger, but it just becomes more negative. So if I come up with another example here, let's say I have y equals, and let's say I already have a coefficient of 3, and I have 3x to the negative 4. When I find my derivative, dy dx, I'm going to bring the negative 4 down, and it's going to multiply by the 3, giving us negative 12x, and then negative 4 minus 1 is going to give us negative 5. And just know if you wanted to, you could always rewrite these answers with positive exponents. You could write this one as negative 2 over x to the 3rd, and we could write this one as negative 12 over x to the 5th power. Okay, so this is the example when we have negative exponents. The next case that's worth looking at is what do we do when we have linear functions? So sometimes the simpler the example is, the harder it is to use the power rule. But anytime I have a function in the form of y equals mx plus b, the derivative y prime is just equal to m. Remember, the concept of a derivative is the derivative tells you the slope of a function. So in the case where our function is linear, the slope is always constant, and the slope is the coefficient of x. If we had a case where our function was just y equals k, where k was constant, this is another type of linear function where the derivative of a linear function that's just constant, that slope is equal to 0. Okay, so just know, anytime you have something like y equals k, it's a horizontal line, and a horizontal line has a 0 slope. So if we use that idea for questions like this, if I had, let's say, f of x is equal to 1/3 x plus 12, without thinking too hard on this one, I just have to look at what is the slope of my linear function here, and the slope is the coefficient of x. The slope is 1/3. So, if we just come up with another example here, let's say g of x is equal to square root 2 times x plus 5. Even though our slope here is irrational, it doesn't matter. Our derivative is just going to be the slope no matter what number it is, and that slope is square root 2. Now, the only trap that they throw you with the numerical examples, like if they gave you something like y is equal to 5, this example is very obvious that the derivative is 0. But let's say they give you a situation here where, let's say I have h of x is equal to pi to the third power. If someone's not careful, they're going to say that this is 3 times pi squared. They're going to want to use power rule on this, but just know pi to the third, this is just a number. So when we take the derivative of a constant or a number, that derivative is just 0. So just be careful with examples like this. Remember, it doesn't matter how wacky the number looks. If I had something like y equals pi to the third plus square root of 3 times e to the natural log of 5 plus radical 2, something absurd like this, that's just one number, and the derivative of a number is just 0. Okay, so just know that these two ideas, this is some of the trickiest ways that they could appear. Now, the next example that's worth looking at here is what happens when our exponent is a fraction. So in a situation where you have a fraction for an exponent, let's say I have y equals x to the 2/3 power. It really helps to know the shortcut for subtracting 1 from a fraction. So this trick works pretty well. So if I want to take the derivative of x to the 2/3 power, I'm going to have 2/3 times x, and when I do 2/3 minus 1, I'm going to use this trick. I'm going to do the numerator 2 minus the denominator 3 over the denominator. And this could go on in your head. This is going to be 2/3 x to the negative 1/3 power. And this trick is going to work because if I subtract 1, just know I could subtract 1 in the form of 3 over 3. And in a situation like this, I subtract 2 minus 3, that's our denominator 3, and I keep the denominator the same. All right, but just know you don't have to do this subtraction every time. Just use this nice shortcut, and it's going to help you go through these examples quickly. So if I had something like, let's say y equals x to the 5/7 power, then my derivative dy dx is going to equal 5/7 x. And if I do 5 minus 7, I'm doing numerator minus denominator. I'm going to get negative 2/7. So this is just a nice little shortcut so you could subtract a little bit quicker. Now, the only little change that we can make to these questions is, let's say I have f of x equals 2 times x to the 1/2 power. So in a situation where you have a coefficient, you just leave the coefficient alone and you take the derivative of x to the 1/2, and you've got 2 times 1/2 x to the negative 1/2. Remember, I'm doing numerator minus denominator over denominator, and then 2 times a half would just cancel out. So our derivative here would just be x to the negative 1/2 power. So this example here for fractions, remember, just use that nice trick. And we could also deal with negative fractions. What if we have something like g of x equals negative 3 times x to the negative 1/3? Well, in a situation like this, we could still use that trick. We have negative 3 is going to stay put, and then we bring down the exponent. We have negative 1/3 x, and we're doing numerator minus denominator over denominator. So when you do negative 1 minus 3, you're going to get negative 4/3. And then here I have a negative 3 times a negative 1/3. These are going to cancel and make positive 1. So we have a negative times a negative is positive, and this is going to make x to the negative 4/3 power. So that's our solution to this one. Now, the last case that we have to look at is what happens when we are given radicals. So you have to know a little bit of algebra for this one. If you have something in the form of the c root of a to the b power, we know we could write this as a to the b over c. The idea is that we write the power over the root. So if I was given an example of, let's say, y equals the cube root of x squared, I would have to be able to do a little bit of algebra first. And in a situation like this, just know I would have to rewrite this as y equals x to the 2/3 power first before I could do the derivative. Don't make the mistake. It would be very tempting to just write y prime equals the cube root of 2x. This is a very common mistake for questions like this. But just know that you have to switch it into power form first. And then you could go ahead and take the derivative. dy dx is equal to 2/3 x. And then I'm doing numerator minus denominator. So I'm doing 2 minus 3 is negative 1/3. And here's our derivative here. So this is an example, once again, where we have radicals. Now, the last case to look at is what happens when we have something in fraction form where x is in the denominator. So if I had something like, let's say, 1 over the c root of x to the a power, or I'll write it in terms of a and b. So let's say this time I write here like this. What I would have to do for this is I would have to write it as 1 over x to the power over root, and then I would have to send this back up as a negative exponent. Okay, so in the simplest case here, let's say it's something like y equals 1 over x squared. Just know you should rewrite this first as x to the negative 2. Don't do y prime is equal to 1 over 2x. That's not going to be right. So in a situation like this, y prime would equal negative 2x, and we're doing negative 2 minus 1 is negative 3. So we have to know how to deal with x's in the denominator here. But now let's combine all of that and have a radical in the denominator. So for the last question here, let's say we had something like f of x equals 1 over, and we have the 4th root of x to the 3rd power. So in a situation like this, I'm going to rewrite this as 1 over x to the 3/4 power. And now I could send this back up as x to the negative 3/4. So for the most challenging power rule questions, what you have to be good at, you have to be good at the algebra required to take this expression and turn it into x to a number power. Because then you're able to just take this and do the derivative all in one shot. So you have negative 3/4 x, and we have negative 3 minus 4. We're doing numerator minus denominator to get negative 7 over 4. And then here's our answer to this example. And you know what I think I'll do here? I'll just make one more example, but I'll make it a crazy one that summarizes the majority of the rules that we've looked at so far. Okay, so last question. Let's say I make this one h of x is equal to, and let's say we have 3 over x to the 4th, and we'll say minus the 5th root of x to the 3rd power, and then plus 1 over, and we'll go with the 7th root of x squared. So in this situation here, we have to write everything in power form. And remember, when we're taking the derivative of a function with more than one piece attached by addition and subtraction, we're just going to take the derivative of each piece going from left to right. So the first thing we would do is rewrite every piece. 3 over x to the 4 is 3x to the negative 4. And then this is going to be minus x to the power over root. So the power is 3 and the root is 5. And now we have plus. And on the side here, I'll just go on a little side quest. We have 1 over x to the power over root is 2 over 7. And now if we rewrite this, this is x to the negative 2/7 if we send it back up as a negative exponent. So this is plus x to the negative 2/7. So now to close this question out, h prime of x, we're doing negative 4 times 3 is negative 12. X, negative 4 minus 1 is negative 5. And then we've got minus 3/5 is coming down. X, and we're doing numerator minus denominator. 3 minus 5 is negative 2. So we have negative 2/5. And now the negative 2/7 comes down. We have negative 2/7 x. Negative 2 minus 7 is negative 9. So we have negative 9/7. And this here is our final answer to the last question. So this is going to wrap all of this up. Okay, well, this is going to conclude this power rule for calculus video. If you found this video to be helpful, please like and subscribe. It really helps me grow the channel. And if you got any requests, just leave the topics you want me to cover in the comments section below. And thanks for watching.